Hello friends, welcome to sitza.com. Now in this video we will learn about the IUPAC nomenclature of the cycloalkanes. In the cyclic compounds we use a prefix term here, the cyclo first. It represents that the molecule is cyclic and the number of carbon atoms here in this molecule are 5 and we only have the single bonds. Okay, so we have 1, 2, 3, 4, 5 carbon atoms only with the single bonds there, so it's a cyclopentane. The name will be cyclopentane. Here in this molecule there are 6 carbon atoms and it is cyclic, so we use the term first cyclo, and then 6 carbons means it's a cyclohexane because they are only single bonds, right? And this one will be called as cyclobutane, and this is a cyclopropane. If there is a substitution around a cycloalkane, the molecule will be called as a alkyl cycloalkanes. Suppose here this is a cyclohexane. This molecule is a cyclohexane, and if you attach a methyl group to it, it will be called as a methyl cyclohexane. It will be called as methyl cyclohexane. Methyl cyclohexane, and this one it contains 2 carbon atoms, so it is the ethyl cyclohexane. If you have more than one substitutions, then we have to first give the numbering, but numbering should be done so that it does not violate the lowest set of a Lucan rule. Okay, suppose we have 2 methyl groups around the cyclohexane, so I'm going to write down number one. This one will be the number 2, this one 3, 4, 5 and 6, right? I can't start from here, then it will be the 1, 2, 3, 4, 5. It will be the 1, 5 the other way, right? But here it is 1 and the 3. The 2 substituent groups get the position of number 1 and the number 3, the lowest set of Lucan rule, right? So it is 1,3 dimethyl. This is 1,3 dimethyl cyclohexane. 1,3 dimethyl. This is 1,3 dimethyl cyclohexane. Here in this one we again have the 2 substituent groups, but the 2 groups are different. This one is a methyl and this one is ethyl group. There are 2 options for the numbering for this molecule. If I provide this one as a number 1, then this will be the number 2, so ethyl will get the number 2. But when the set of alkanes is same, right, then we give the preference, we do the numbering according to the alphabetical order of the groups, right? We write down the numbering of the carbon atoms in the ring is done in such a way that the substituent which comes first in the alphabetical order, that means here ethyl E, it comes first in the alphabetical order, right, is given the lowest numbering, provided it does not violate the lowest set of Lucans. Means if I do the numbering 1 here, this is the number 2, then this is number 3, then here it will be the 3 ethyl and 1 methyl. But there is a one more option. If I provide, if I give this carbon as the number 1, this will be the number 2 and this is the number 3. The set of a locant in both cases is 1 and the 3, right? In the first one it is 1 and the 3, in the second one it is also 1 and the 3. So set of a locant, the lowest set of locant is the same. Set of locants is same, but now since ethyl comes first in the alphabetical order, so therefore we give the lowest number to the group which comes first in the alphabetical order. So that's why this numbering is correct, this numbering is wrong, right? So when we name, it will be called as a 1-ethyl. It will be called as 1-ethyl 3-methyl cyclohexane. Now in this molecule, we'll start the numbering from this one, 1, 2, 3 and the 4, because the set of alkane now will be 1, 2 and the 4. If you do the numbering from here, it will be from the 1, 2 and 3, so it will be 1, 3 and the 4. So the 1, 3 and the 4 is wrong, right? It's not the lowest, so the correct one is 1, 2 and the 4, right? If you start the numbering from this particular carbon, it will begin the number 1, this will be number 2, this will be number 3, and this is the number 4. Then the set of alkanes will be 1, 3 and the 4. But if you do the numbering from here, from this carbon, it will be number 1, 2 and 3. So it gets the 1, 2 and 4, right? 1, 2 and the 4. 1, 2, 4 is the correct one, because this is the lowest set of alkane. You can also start the numbering from here, but in that case, if you do the number, to the ethyl, to this group, it gets the number 1, this carbon gets the number 1, this will be the number 2, this will be number 3, 4 and 5. So it will be 1, 2, 5. Again, that's wrong, right? So that's not the lowest set of alkane. So the lowest set of alkane here you get when you start the numbering from this particular group. So it gets the number 1, this is number 2, and this is number 4. So when we name, we write down the groups according to their alphabetical order. So ethyl E, it comes first. So the name will be now here, it is 2-ethyl, right? This is 2-ethyl 1,4-dimethyl 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 cyclohexane. Here in this case, we'll start the numbering from this particular carbon. It will be number 1, this will be the number 2. And when we name, the ethyl will be written first. So it is 2-ethyl 2-ethyl 1,1-dimethyl 1,1-dimethyl cyclohexane 1,1-dimethyl cyclohexane. Now in this molecule we got a cyclohexane ring, and it has alkyl group that contains 3 carbon atoms. So the name for this molecule will be, it will be propyl cyclo, it is propyl cyclohexane. Okay, but if in an alkyl group the number of carbon atoms is more than the number of carbon atoms as you find in the ring, suppose here in the ring you find we have only 5 carbon atoms, and in the alkyl group there are more than 5 carbon atoms. When the number of carbon atoms is more than 5, so we take this cycloalkane as a substituent group. So we take it as a substituent group. So therefore the name will be, now we'll start the numbering to this alkyl chain. Okay, this is considered to be the derivative of a alkane, right? Alphabetical alkane, and the ring will be considered as a substituent group. So here's the number 1, number 2, 3, 4, 5, 6 and 7, right? So it will be 3. We have a cyclopentyl ring as a substituent group. This is the 3 cyclopentyl, 3 cyclopentyl, right? Why it is taken as a substituent group? Because the number of carbon atoms in the ring are less, right, than the number of carbon atoms present in the alkyl group, right? So it is 3 cyclopentyl, 7 carbon atoms, so it is heptane, In this one we have less number of carbon atoms, right? Here in this molecule we have got 5 carbon atoms, 1 2 3 4 5, and here also 1 2 3 4 5. Okay, if the number of carbon atoms in the ring is equal or less than the number of carbon atoms in the chain, in the alkyl group, then we take this alkyl group only as a substituent group. So here for this molecule we find there are 5 carbon atoms in the ring and 5 are here, right? So therefore this is the substituent group, alkyl group is the substituent group, so it's a cycloalkane, a derivative of a cycloalkane. The alkyl group will be considered as a substituent group, so it is pentyl, 5 carbon atoms, 1 2 3 4 5, so it is pentyl cyclopentane, pentyl cyclopentane. If for example we got the cyclopentane but the number of carbon atoms in the ring is more than that, is more than 5, 1 2 3 4 5 6 7, so then it's called what? It's a substituent group, right? So this is the substituent group, and we'll write down the numbering to the alkyl chain. Number 1 this one, number 2 this, 3 4 5 6 and 7, right? So this is the heptane, and this this cyclopentyl is present at the carbon number 1, so it is 1 cyclopentyl heptane, like here, right? The difference between the two molecules is that we have a cyclopentyl ring here at the carbon number 3, here is at the carbon number 1. So the point here is, if the number of carbon atoms in the ring is less than what we find in the alkyl chain, then only we take the ring as a substituent group. If the number of carbon atoms in the ring is more or is equal to the number of carbon atoms present in the alkyl chain, so then it's the alkyl cycloalkane. The alkyl group is taken as the substituent group, not the cycloalkane. Like here, pentyl, 5 carbons in the ring, pentyl cyclopentane. Now in this molecule, if I attach a ring here at this position, let's say over here, if I attach here a ring, a 6-member ring, so what will be the name? Since in this ring, in this chain here we find 1 2 3 4 5 6 7 8 9 carbon atoms, and here in the ring there are only 6, so cyclohexyl ring, right? This is taken as a substituent group. Cyclohexene, cyclic ring, this is taken as a substituent group. So the name for this molecule will be 1 2 3 4 5 6 7 8 and 9. This is 3 cyclohexyl, 3 cyclohexyl nonane, cyclic molecules which contain a double or a triple bond accordingly will be given the name. So this molecule is a cyclic molecule, is a cyclo, this is a cyclo, and it contains 6 carbon atoms, but there is a double bond, so it will be called as cyclohex because it contains 6 carbon atoms. So it's a cyclohexene because of the double bond, so you get E and E there, cyclohexene. So this will be called as cyclohexyne because of the triple bond. So Y and E we use the term. This is a cyclopentene. This is a cyclopentene, 1 2 3 4 5, and this will be called as a cyclopentadiene because there are 2 double bonds, so it is the pentadiene, right? Cyclopentadiene. If you have a substituent group again around a ring which contains a double bond, the numbering is done so that the double bond gets the 1 and the 2 numbers, right? So I'll start from here, number 1, and this will be given the number 2, and this will be given the number 3. The numbering in the cyclic ring is done so that the double bond gets the number 1 and the number 2 there. Okay, fine. So when we name it, it will be 3-methyl, right? It will be 3-methyl here, 3-methyl cyclohexene, right? 6 carbon atoms in the cyclic ring, cyclohexene. Okay, if you have a double bond here in the alkyl group, not in the cyclic ring, so no matter what is the length of this carbon chain, always we'll take this one as a parent chain and the cyclic ring will be considered as a substituent group. Okay, so when there is a double bond or a functional group is present in the alkyl group, the cyclic ring will be taken as a substituent group always, no matter whether the number of carbon atoms in the ring is less or more than the number of carbon atoms present in the alkyl chain. Because of the double bond, this double bond, this alkyl group will be taken as a parent chain. So numbering will be done like this: 1, 2, 3, 4 and 5. The double bond should get the least number, right? So when we name it, this molecule, this will be called as 5-cyclohexyl pent -2-ene, pent -2-ene, because the double bond starts from the carbon number 2. So again, let's take this example. We got a cyclic ring, a 6-member cyclic ring, but we have 1, 2, 3, 4 carbon atoms in the ring. But because of the functional group OH in the alkyl chain, this one will be taken as a parent chain and the cyclic ring will be taken as a substituent group. So this number, this CH3, it gets number 1, number 2 here, number 3 here, number 4 here. So the name for this molecule will be 4-cyclohexyl, 4-cyclohexyl, okay, butane, right? This is the butanol actually. So we say that it is the butane 2-ol, right? Butane 2-ol. Why? Because the OH group is present on the carbon number 2, right? This is the butane 2-ol, 4-cyclohexyl butane 2-ol. And this molecule, it contains the COH group, carboxylic group here. So this will be given as the number 1 and this one as the number 2. The cyclic ring, no doubt it contains more than 2 carbon atoms, it contains 6 carbons, but still it will be considered as a substituent group because of the functional group here, right? So it will be 2-cyclohexyl, 2-cyclohexyl ethanoic acid, right? Ethanoic acid, because of this COH. Hope you got the concept. Thanks for watching the video. Bye for now.